computer, I guess. All right, so we are recording now. So no cameras, no cameras. I don't want your camera on because this goes public. I've done it private, but it's a pain in the butt because some kids can't get on it. So we're just going public. So therefore, do not turn your cameras on. Okay, I'll share the screen. Hope this cable works again. Please work. Yeah, baby. All right, so it works. Now, this is what we did last time. So now it's being recorded. So I suppose anybody that takes the time to watch the recording is going to have a pretty good, get some pretty good points on this thing. But that's all right. You know, if you took the time to watch the recording. Anyway, we talked through this last time. So check to make sure you're right. And later on, we can go through this again. I don't want to waste people's time that have already been there to go over all this again. This was the three-dimensional walk, and it's 4 phases. I'm not going to spend much time on this, but we already talked about it. But if this happens to make it on the test, and I haven't written the test yet, but you need to not just specify. You can't just say, okay, he's walking east. To get the full points on each phase, you have to say at what speed they're walking. Or like in phase 2, you're climbing a ladder, you know, you're going up. You're not climbing steps because you're not going to the left or the right. You're just going up. Hold on a minute. Hold on a minute. Hold on a minute. Let me move that over there. I normally run 2 or 3 screens, but lately my internet's so terrible. I'm going to get that fiber. It just hasn't got set up yet. Anyway, so that's what you got to watch out for, is to make sure you're also giving the speeds. And the other thing is phase 4 was weird but we've done this now out in the hallway. Phase 4, you're moving in the X, you're moving south and you're moving east at the same rate. That happened to be 45 degrees. And then as a bonus, last time we also worked number 4. And hopefully I would say 90% of you did this because I went around and checked. So great. You tried it. Now here's the answer. I don't know what the answer is. We did all the numbers. I'll let you punch the numbers in, but you know, I'm not going to waste your time by doing that online here, but yeah, you know, that's how you do it though. And now this has been recorded, so you can go back and watch it later. We talked about 5 through 12 a little bit. We didn't do a lot of those. We worked on 9. Before we go on to tonight's what's due tomorrow, tonight we need to cover what's due tomorrow, what's due Monday, you know, because we'll do this again Monday night and we can talk about Tuesday there. But also Monday night, I want to be able to go through all of them like I'm doing now, but go through all of them. Not with this, it's not really a key. I'll post the key on Wednesday afternoon, early afternoon. So you'll have it, just go back and double check and make sure that you didn't make any dumb mistakes. And you can either verbally ask your question, or you can, that's kind of how we did it last time, or you can just go to the chat and you can ask your question that way. But ask it publicly so everybody sees your question. All right. 5 through 12. Before we move on to 13, anybody want to ask a question on 5 through 12? Going once. Okay. Second question, please. You mean 6, right? Yeah. Tell me the number of the question, because I'm going to say second. I'm guessing you're mean number 6. Okay. 6. Let's do 6. Why not? So always good to get the juices flowing here. -10. I got to circle that. Giga is 9. Centa is -2. So I'll play the game. -10 plus 1 is -1. You add these numbers, you add the powers on the left side of the equal sign, you subtract to the right. So -1 minus a -2 is 3, or another way of saying that is 3,740 E. And go ahead and put the letter out there. Can we go over the first page? I went over the first page at the very first of this. This is recorded, and I talked about the first page. I showed the problems there. So those are there. You can look at them. If that still doesn't make sense, feel free to come in tomorrow at lunch. I'll be there tomorrow till 12:40. Okay, if you want to come in at lunch tomorrow. Or you can Zoom. We Zoom again on Monday. But any other questions on 5 through 12? 5 through 12. All right, we got some bigger fish to fry here. 13. 13 is a little like, it's actually easier than what we did in the hallway today. It says plot the y versus t and the x versus t graph for the following journey, assuming you can only walk on the axes. See, we were doing a lot more than that today. Start at the 6-meter I roof and walk at a speed of 0.5 meter a second to the final position of 4-meter J roof. So what that, you're not going directly from 5-meter I, or 6-meter I roof to 4-meter like we did today. You're having to walk down to the origin and then turn, it looks like, yeah, you would turn right and walk up to the 4 meters on the J. So you're supposed to plot the J and the I. So if you start in the I, you would start, I'm not going to do the whole thing. Okay, I want to leave something to the imagination, but you start at the 6, right? And then you're going to walk at a speed of 0.5 meter a second. So it would take you how long? Now, the faster you answer me, the faster we can move on. How long would it take you to move to the origin? $12. You don't need a direct message me. Say it to everybody can see it. 12 seconds. And so you know that at the 12-second mark, you're going to be back at the origin for the X. Now, while that was happening, the Y wasn't doing anything. So that first little bit is 12, right? The first 12 seconds, the Y is asleep. And then I'll leave it up to you to finish it, the second half, right? The whole time we are walking at a speed of 0.5 meters a second. So I'll let you, it ends at 20 seconds. We'll say that much. Okay. Enough said. Let's go on to 14. 14's like the Donald Trump. 14's like Dr. Beck jogging. Basically the same thing we did today in class. You're walking, this time you're walking along on the first floor of Penn Square Mall at 3 feet a second for 10 seconds. Okay. So we're walking on the floor. So we're not going up or down. We're assuming this is a profile view. So X is horizontal. So in both cases, we'll start at 0. I'll make X my orange. We walk along at 3 feet a second for 10 seconds. So obviously we're at 30 feet, right? And in the Y, nothing's happened. Whoa, we're at 30 feet, but we are making progress. So 3 feet a second. So at 30 seconds, I'm sorry. Wrong. I haven't worked the key out yet. In 10 seconds, we've gone 30 feet. So boom. So you're going to end up boom, like that, right? And then the Y for those 10 seconds and nothing's happened. Okay. So you were asleep in the Y. You get to the escalator and continue moving at a speed still 3 feet a second for 20 seconds. So that's why did I go all these 70 seconds in? I think I got confused. Anyway, looks like my x-axis is way too long, unless I'm seeing it wrong. Because we just went a total of 30 seconds. I don't know why it goes to 70. I don't know. I wrote this problem last week. Anywho, So you go up, you get to the up the escalator, and you continue moving at a speed of 3 feet a second for 20 seconds. But now you're moving, you're going along here, and then we'll go this in black, we'll go green. So you're going along here, and then you're going up the escalator. So you're right here, that's at the 10-second mark. And then at the 30-second mark, at 30 seconds, you're right there somewhere. I guess you're up the escalator. Yeah, I got my seconds confused with my position or something. Anyway, it'll still work. And so I think, and so we have a X part of that, and we have a Y part of that. And I'm going to go ahead and make, since that's all X, I'll just make that red or orangish. Okay, so here's where you got to use, if it's 3 feet a second for 20 seconds, then what is the length of the escalator? Here's where I was getting my axes messed up. What's the length of my escalator if I went up it for 3 feet a second for 20 seconds? I'm throwing you softballs here. 60 feet. So we're 60 feet up the escalator now. So now you got to do that 30, 60, 90 thing, right? If that's 60 feet, the sine of 30, 60. So this will, let's just say this. Let me blow this up. This is sort of this is your profile view. So on this blue axis, we're looking at 60 sine, and I'll clean this up for the key, 60 sine 30. And then on the red axis, we're looking at 60 cosine 30. And that's always, I know it's new to you now, but that'll always be the case all the way to May, that as long as the angle's from the horizontal, the vertical, I think Grace was asking this, and I just said, okay, look, I'll tell you this much, at least until spring break, the vertical will always be sine, the horizontal will always be cosine. And the reason is I'll make the angle from the horizontal. So sine of 30 is 1/2. So this is going to be 30 feet. And cosine is root 3/2. It's a little harder. So cosine 30 is not so nice. So we have to say 60 cosine 30, and we get 51.9. I'm just going to say 52. It's 51.96. So 52 feet this way. So, and this is, we've had a little experience now with this today. So it looks like you're going 52. I'm not going to finish this problem. I'll let you finish it. You can help each other. But it looks like we're going to go 52 feet more in the X in those 30 seconds. So we'll end up at, in those 20 seconds, a total of 30. So this is not the best problem in the world. It ends up, looks like it cuts off right there. We're not going to need any of that. It's not the first time I write a problem. There's always some dumb thing I do. Anyway, so 52 feet. So you were at, where were you at? You were at 30 feet. You had gone 30 feet so far. So it looks like we're going to end up at 82 feet, which is now going off your daggone graph. Okay, fine. 30 plus 52. So we'll be up in here. So you're going to go Dunkov. You do slow down in the X a little. There's a little bend there. You have to slow down in the X because now part of your speed is going into the Y. It's if you look at the speed doesn't change, but the velocity does, because the velocity, some of the velocity stays in the X and some of the velocity goes in the Y. Yeah, so there's a little bit of bend there, and that's going to end up at 82 feet off the graph. My bad. When I make the key, it always seems so obvious. All right, and then the other one, we go 30 feet in the blue. I'm just, since I went off the graph, I'm going to have to show you. I got that right at least. End up like that. So, you know, you lost some of your velocity in the X, but you gave it to the Y. Jesse's asking, Can we go back to question 6? Oh, hold on. You calling me a liar? Let's take a look. So on question 6, go back to question 6. Oh. No, that's right. Yeah. Oh, what you're saying is, I see. Take on it. I need to wake up. I was taking a nap. All right. So on and this, now Jesse's on to possible 2 stamps here. If you correct me, it's 2 stamps. So -10 plus 9 is a -1. -1 minus a -2 is like saying plus. I can't do arithmetic. So it's like 2 minus 1. It's like 10 to the first. And that would be C. Ooh, Jesse for the save. And Carson says, no, it's D. Hold on a minute. -1 plus 9 is -1 plus 9 is -1. -1 minus a -2 is -1 plus 2, which is 1, which is 10 to the first, which is 37. Okay, so these things fool me sometimes. A stupid metric game. Okay, so Jessie was correct to send me back, so she gets the 2 stamps. Okay, just for that, let's do another one. All right, number 7. Let's do 7. 7's weird. Blow that up a little bit. So on 7, we have 10 to the first, and second, and third, and fourth. -4 goes above that. -4. I think on my own test, I'd probably get a B. Nanoseconds is -9. Milliseconds is -3. Okay. Now we go back and do my arithmetic. -4 plus -9 is -13. -13 plus 3 is -10. Boom, C. I am so smart. I need some water or something. I'm getting parched. All right. Okay. Hey, let's do one of these best way to writes, because that always bothers people. I feel like I owe it to you since I messed up on number 6. Let's go to 12. What is the best way to write 500 times 10 to the -13th megaliters? Okay, so let's do the thing first. That's 2. That's a -13. That's a 6. So let's see where we are. 2 minus 13 is -11, plus 6 is, what is that? -5. -5. So all these add up to -5, if I can do math. Okay. Yeah. So now, what's a better way to write it? -5. I was at the megaliter stage. I was up here at the mega. It's not meters, it's liters, but I was up here at the mega. And so I want to find a better way to write, so I don't need to say -5. So I come down -5, which puts me at right above 10 above. This is 1, puts me at right above the, or power of 10 above the meter, above the base unit, which in this case would be liters. So this would be 55 times 10, 50 liters. Hope that's an answer. Yeah, baby, right. Oh, no, wait. Okay, hold on. Oh, whoa. I'm trying to play the metric game there. Let's try it again. This one's tricky because normally it's just, you got a quick change here, but it's 500 times 10 to the 13th megaliters. So that's like saying, oh, -13th, but it puts me at, okay, but I'm at mega. I was right. That's negative. Oh, -5. Hello. Okay, so I was at -5. So I'm it's like saying this. It's like saying 0.00005 megaliters. Okay. That is like saying 50 liters. I didn't make that. I made this up last year, 2 years ago. I made this problem up. Check me on this. Am I going crazy? I'm not seeing my answer. I think 50 liters is right. Oh, hold on. Oh, no. I'm seeing it wrong. I'm sorry. All right. Man. Try it again. Okay, mega. Let's do it this way. Mega drop 13. Mega puts me down. If I drop 13 from that drops me down to way down here to the micro, right? There you go. That's what I was doing. I was doing it wrong. Drop down to the micro. I need to get more sleep. And that would put me at 10 below a micro, but I'm saying 500. And that puts me 10 above a micro. So that puts me at 50 microliters. Okay, I knew it was 50 something, 50 microliters. So what you do is you say, okay, mega, and I'm going 13, drops me 13 powers below a mega, which puts me at 1 below a micro because it's 12. 6 to negative 6 is 12, add 1, 13. And then I said 500. So that puts me 2 more powers of 10 above, which puts me at 50 microliters. Okay, at least the problem's right. I'm just having a hard time tonight focusing for some reason. Okay. Okay, let's do another one since I messed that one up. Let's try it again. Let's do 11. 11. I'll do this in green. So what's the best way to write? Now let's do this right. All right, picograms, 10 to the 16th. Pico's down here. I jumped 16 up. That puts me at 10 above a kilo, right? Because that's 15 plus 10. So I'm at the kilo. And it's not 500, it's not 80, it's just 8. So 8 times 10, which is 80. That puts me at 80 kilograms. B. Stake my life on it. Well, I'm not going to go that far. BA. Okay. That's all because of Jesse. 15. Okay, yeah. Okay, we're gonna look at 15 now. All right, so 15 says, determine the necessary arrangement to add vectors with the following magnitudes. So first off, it says, this first one's easy. It says 5 plus 12. Oh, no, it didn't. Let's go to the easy one. 5 plus 12 equals 17. Okay, 5 plus 12 does equal 17. That's if they're lined up. So what I want you to do is you would take, we'll go blue. You would take, this is 12 units long. I'm going to add my ruler. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Boom. And the resultant or the combo is 17. Okay. So that's easy. Now let's go to one a little harder. 5 plus 12 is 13. Now, this is, okay, there's Pythagorean trios. There's a 3, 4, 5, right? And ACT is coming up, SAT is coming up. So you got to know these Pythagorean trios, right triangles. If one leg is 3, one leg is 4, the hypotenuse is 5, right? Most people know that one. But here's the one they always use as well. If one leg is 5 and one leg is 12, the hypotenuse is 13. So knowing it's a Pythagorean trio, my other leg would be 5. 1, 2, 3. Whoops. That's already 12. So 1, 2, 3, 4, 5. And then the resultant, I'll make that in red. The resultant goes from the very beginning to the very end. And there is a situation. Remember, I was holding the arrows, the wooden arrows above in front of class, and I was saying, look, you can add these up. You can put these together, or you can move this back. So that's 5 plus 12 equals 13. And it forms a right triangle. You with me so far? Oh, use your little buttons there to give me a thumbs up or thumbs down. One thumbs up, two thumb up. One. Oh, Carson says, whoa. Okay, we got 3 thumbs up. And it's not like the test is tomorrow. You can always come ask questions. You can ask a quick question in class. I'm obsessed with coloring in triangles. So that's your right triangle there. Now let's go to this one. This one's a bit of a stinker. 5 plus 12 equals 7. Why would I put that? Why would I put that in the far left? Why wouldn't that be on the far right? That was stupid. Whatever. I should have done the opposite. Ugh. Make a note. Next year, opposite. Pedagogy. Okay, so 5 plus 12 equals 7. How am I going to do that? Anybody got a suggestion? I'll tell you what, the fastest way to do it is to get a compass. I don't mean like a look around compass. I don't have a compass with me. So since I don't have a compass with me, I doubt you do too. Who was that who had a compass? Somebody had a compass in class the other day. They got points for that. I'm going to do this. I'm going to do this here. Let's do it this way. Here's another way to do this. 5 plus 12 equals 7. I'm trying to find a way to get 7 out of this. So, yeah, take a look. If I'm looking at this, I want something that's 7 units long. So that's going to be my answer. So the resultant's going to be 7. If I do it this way, the resultant is 13. So that's too long. So I know and if I do it this way, the resultant 17. So I know it's going to be something along these lines. And tell you the truth, on a test, I don't think I'm going to get a ruler out or anything. It's going to be something like this. And then my resultant's going to be, I'll give you something and then we'll do it right. It's going to end up looking something like that. And to be honest with you, if I saw that on a test, I would give you credit and move on. But to do it right, what you would do is this, if you want to do it right. Absolutely right. You would find out how long 5 units is. I'm going to use my ruler. 1, 2, 3, 4, 5. And I would go along. If I had a compass, I would just write a circle with the radius of 5. There it, and let's go blue. There it is. Now I'm going to go, hold on. What is this? All right. No. Yeah. 1, 2, 3, 4, 5. It looks like it's right there. 1 at the 1.5. Okay, then I'm going to go here. I'm going to do a couple of these and get a semicircle going. If I had a compass, like I say, I'd have this done in a flash. I'll get enough of these with a radius of 5 that eventually I'll hit it. Okay, so I got an arc here. This arc. I know it occurs somewhere along this arc. And then you did this in geometry, actually, something kind of like this, when you're bisecting angles, that kind of stuff. All right. And then I come along and I get one that's 7. And let's see, 1, 2, 3, 4, 5, 6, 7. That puts me right there at 2.5. Okay. Then I go over here. I go, okay, that's going to be, I'm going to keep going here until I hit it. Now I got to keep going, it looks like, on my arc a little more. And it ends up like right here. That's it. Right there, I hit it. And then that would be my 5. So this is real fast with a compass, but a little slower with a ruler because you have to kind of get an arc. You have to draw an arc. But the point is that in vector world, all those things can happen. This is a bit of a preview of really what's going to happen more in packet 3. So take that with a grain of salt. We didn't talk about it in class much. Sometimes I throw something on the take-home test to see, just to kind of give you a preview to make you think about it for a little while. But I would never put that on a test, if you get my drift. I'm not, never say never, but let's say there's a 90% chance I ain't gonna be on the test. Okay, look at that, 16. Now that takes care of tomorrow, for the dogs tomorrow. But now we're looking at Monday's dogs. We got about 13 minutes left. 16 is like what we did today. Only this time I gave you the map. It's a map view, not a profile view. I gave you the map view. So we're starting at the 20, ended up, so you see what we're doing there. X versus Z. I made it a Z axis rather than a Y axis. It's actually easier than what we did today, to be honest with you. I don't know. It's about the same. Hey, I'll tell you what. After tomorrow, this one's going to look like a walk in the park. Okay. So maybe we want to wait till tomorrow on this to worry about this one. Maybe we'll knock it out tomorrow in class. How about that? Maybe. We got to work on sheet number 9 too. Let's look at 17. 17 is always one that a lot of students miss, and it drives me crazy. Okay, why they miss this one? But this was the pinwheel activity. So here's a problem from the pinwheel activity in the courtyard. Assume the class lines up along the covered sidewalk. Now, we didn't do this because of the goofy freshman tents that were there, but let's assume that we line up along that sidewalk, and we're facing north towards the band building. Okay, the line of students does a pinwheel and ends up facing east towards the main building. You've all done this. Suppose your particular radius from the axis was 32 feet. It takes the line of students 16 seconds to do the entire pinwheel. Okay, so it says determine your omega. Okay, I'm going to shut up for 2 minutes and let you, you probably haven't worked this one, I doubt it. No one really works that far ahead usually. So think about this. Everybody's thinking about it for the first time. Most people are. So think about your omega. But remember, I'll give you this hint that omega is equal to delta theta over time. And so the other hint is it has nothing to do with that 32 feet. While you're working, I'm going to look and see who's here. And we got a few people. All right, Trisha's there. We got Sasha. We got Evan. Boy's there. Angel. Caleb. We got Jesse. Carson's hanging out. Grace. Daniel. Lee. Oh, Leah. Okay. Eric's here. Very good, Eric. Samara. Yeah. All right. That's cool. Caleb there. See Caleb there. All right. So you get it. How far did we go? We went pi over 2 again, 90 degrees, and we did it in 16 seconds. So leave this in terms of omega, pi over 32. Yeah. You could say radians per second or just the shortcut inverse seconds. Draw the omega vector on your drawing to the left. Now, this is the right-hand rule. Hold your right hand up, curl your fingers in the direction of the movement, and notice your thumb. Now, how do you show, somebody tell me or say it or whatever, how do you show a vector going into the page? Don't be shy. Is this thing on? Hello? Show the, how do I show up? Oh, okay. Across in a small circle. Okay. So good. Thank you. Now, where do I put that thing? Like right here or right here, or where do I put it? Where would it make the most sense to put that thing? Down to 9 minutes here. Yes. It's not really the origin. It's the axis of rotation. So you put it right there. It's not the origin. The origin's right here. Not at the origin, although that would be the second best place to put it. But the place to put it is it's curling around the axis. So you put it at the axis of rotation. We had barely mentioned that. That's fine. Okay. Determine your velocity. Now you got to use the mini bridge. I'm not going to do it, but you know the equation for the mini bridge, and you'll get the mini bridge in the reference sheet. And by the way, you should look over those two reference sheets. Don't make Thursday the first time you've already looked it over. And I'll let you solve that, just omega R. Okay, 18. We're still looking at Monday stuff. Yeah, we go through, we do 18 and 19. Isn't that Monday still? There's the ant crawling. Although this time, I'm running low on time, 2/3 the way around a large spherical granite rock. If the ant's angular speed is 0.05 radians per second, so the ant's going to get 2/3 the way around, all the way to there. So if we went all the way around, the delta theta would be 2 pi. And since omega equals delta theta over t, it's not all the way around, right? It's 2/3 the way around. Oh, Patrick got that axis of rotation. It's 2/3 the way around. So, right? I mean, it's 2/3 2 pi. I'm doing a double decker, but that's okay. We'll fix it. Oh, over t equals omega 0.05. So I'm not being a purist here in physics world. In physics world, a purist would start here and go, okay, t then equals delta theta over omega. You do it in symbols first, right? And then I would do this other business, which is going to be 4/3 pi over omega 0.05. Inverse seconds. Notice that's inverse seconds. It's the inverse of the inverse, which makes it seconds, which is what you want. Man, I'm not supposed to give you the answers. What am I doing? I'm just like, I'm supposed to give you hints. Oh, well, when it's not recording this or anything. Yeah. We're recording. I'll edit all that out. Now we get to 19. Last one I'll have a chance to look at. We got 5 minutes here. Because 20 I don't have to look at, right? That's just your I'll tell you what, Monday night we'll probably go over it again just to show you kind of a short. We did the way we did it in 6th hour is the way you should probably do it. Okay. Anyway, now this is a new one now. A hamster's running along the inside. I'm not going to give you the answer. A hamster's running along the inside wall of her wheel so that the wheel is spinning counterclockwise. Uh-oh. Did I mess this up? Because you always got to be careful. Oh, did I mess this up? Oh, I did mess that up. You see my mistake on number 17? A stamp for who finds my mistake on 17. You can say it or you can write it. Anybody? You guys all leave? I talk to myself a lot, so maybe. What about 17? What did I do wrong? There's something to thank. Yes. Now keep going, Angel. Keep going. You got it. Boom, Angel. I knocked it out of the park. That is a negative. Ha. Extra stamp for Angel tomorrow. Love it. So because it was clockwise. Yeah, and I already said it, man. We said, look, we're doing this. Okay. Very good, very good. Makes my heart sing. All right, so we got a few minutes. Leave something to the imagination. ASCII. A hamster's running along the inside wall of her wheel so that the wheel's spinning counterclockwise. So now the wheel's going round and around like this. Okay, counterclockwise. And here's my thing. I think if you guys are understanding what's going on, I don't see any reason why you need to go to Stella's unless you just want to go work on the other part, the part we haven't seen, or go back and talk about this some more. I really don't, you don't need to, I mean, unless you want some coffee, it's up to you. Hamster's running along the inside wall of her wheel so that the wheel is spinning counterclockwise at a speed of 24. That's actual V. What will be the omega of the wheel in inverse seconds? Now, omega is going to be positive now. If it has a radius of 12 centimeters, so the R here is 12. R equals 12 centimeters. Always you should draw as you read. Show the omega vector in your drawing. And we now know it's going to be like this. We know it's going to be a dot. And you can't really show the length because it's a dot. But that's okay. You're showing that it is going counterclockwise, and you're showing that it's, that's basically what you're showing. All right. So it looks like, is this another one of those? Looks like another mini. Looks like another mini bridge. Have we ever going to use the big bridge? I don't know. Okay. So I'll give you that much of a hint. You can do the rest, but there's your equation. All right. Down to 2 minutes. Any last thoughts before we wrap this up? You guys have been a great audience. For all I know, you're playing video games right now, but you're making me believe. Last, we got down to 1.5 minutes. About 90 seconds here before we go off the air. What's the difference between velocity and speed? Good question. Velocity is a vector. It's a vector. It has a direction. Speed is the length of the. It's what's called a magnitude scalar. So it's always positive, but it's the length of the arrow. But velocity is not only the length but also the direction. So velocity is a vector. Speed's a scalar. Okay, Jesse, thank you. And I'm watching my time click away. Okay, so look for this. I'll edit out all my mistakes. No, I won't. It'll be raw, and you'll see it raw here later on. Okay, guys. So I'll see you guys tomorrow in class. It's Friday. We'll play a little Flashback Friday. All right. Looking forward to it. Thank you all. I'll stop sharing. All right. Until Friday, just in a couple hours away. All right. Bye-bye.